Breaking news. At 0156 UTC today, automated anomaly alerts activated simultaneously across multiple space monitoring networks. Data streams from orbital telescopes and deep space radar stations began updating at accelerated intervals, forcing technicians in California, Germany, and northern Chile to pause routine operations. Within minutes, analysts realized they were watching something unprecedented unfold in real time. Today, the impossible just happened. Moments ago, the interstellar object known as 3I Atlas was observed undergoing rapid, measurable changes at a rate far exceeding all prior predictions. Not hours, not days, but minutes. Instruments recorded shifts in motion, structure, and emission patterns that should not be possible under any known natural model. This was not gradual evolution. This was acceleration. This changes everything we thought we knew. If you want ongoing updates on the most mysterious events unfolding beyond our planet, make sure to like, subscribe, and stay with us, because what follows is not speculation, it is observation, and it is unlike anything ever recorded. The confirmation came quickly and decisively. NASA's Deep Space Network flagged the first deviation during a routine trajectory refinement. Less than 4 minutes later, ESA's European Space Network independently detected an unexpected change in Doppler velocity. At the same time, optical observatories in Chile reported subtle but undeniable shifts in reflected light curves, indicating changes in surface geometry. At the Atacama Large Millimeter Array, engineers halted scheduled observations and redirected the entire array toward the object. In Maryland, analysts at NASA's Space Science Division received a priority alert marked with the highest anomaly classification. In Paris and Darmstadt, encrypted coordination calls began before dawn. This was not one instrument misfiring. This was consensus. The James Webb Space Telescope, operating across infrared bands between 0.7 and 9 microns, was retasked within minutes. Hubble followed, cross-checking visible light albedo changes. Radio arrays in South Africa and Western Australia began logging correlated electromagnetic fluctuations, faint, structured, and repeating. For the first time since its discovery, 3I Atlas was no longer behaving like a slow, inert interstellar relic. 48 hours before the current event, the object appeared stable. Orbital models showed a clean hyperbolic trajectory, confirming its interstellar origin. Its velocity relative to the Sun remained steady at approximately 41 kilometers per second. Surface temperature estimates, based on heliocentric distance of 1.6 astronomical units, hovered near 130 Kelvin. Spectral analysis revealed carbon-rich material, water ice, and trace silicates. No jets, no fractures, no warning signs. Then, 29 hours before the alert, the first irregularity appeared. Tracking data from Goldstone revealed a minute but persistent acceleration, just 0.02 millimeters per second squared. Normally insignificant, but this acceleration continued, uninterrupted for over 6 hours. There was no detectable outgassing plume. Solar radiation pressure could explain less than 1/10 of the observed force. 11 hours later, thermal imaging from Atacama showed temperature fluctuations across the surface that violated expected gradients. Instead of smooth transitions, the object displayed sharp thermal boundaries, regions heating and cooling independently, fluctuating by up to 35 Kelvin within minutes. No known natural process could produce such controlled thermal behavior. 6 hours before the present moment, rotational analysis showed another anomaly. 3I Atlas had exhibited a chaotic tumbling motion since detection, but suddenly its rotation began to stabilize.
Angular velocity dropped by nearly 9% without any corresponding energy loss. The spin axis aligned precisely along a single vector, an outcome that should require an external torque. Then came the moment that shifted concern into disbelief. At 0156 UTC, real-time interferometric imaging resolved a rapid structural change. The object's projected silhouette altered measurably over a span of just 22 minutes. Elongated contours compressed, lateral dimensions expanded, overall volume remained constant. This was not erosion, this was reconfiguration. Measurements indicated a 12% change in aspect ratio, achieved without fragmentation, mass loss, or detectable heat release. Spectral signatures remained stable. Gravitational influence on nearby dust particles did not change. No known law of physics allows a solid body to do this. Emergency calls were placed across institutions. Dr. Helena Fisher at ESA initiated a cross-agency anomaly protocol. Dr. Michael Trent at Caltech ordered immediate N-body and structural simulations. At Harvard, graduate researchers were instructed to suspend all related modeling to focus exclusively on the new data stream. As the hours passed, the pace of change increased. 3 hours after the initial reconfiguration, ultraviolet spectroscopy detected faint emission lines pulsing at regular intervals. The dominant line appeared at 121.6 nanometers, hydrogen Lyman alpha, repeating every 17.9 minutes. The signal strength was weak, but the timing was exact. Radio telescopes soon followed, detecting broadband emissions between 1.3 and 1.6 gigahertz. Not narrowband communication, not noise, but modulation with mathematical precision. Pulse intervals followed a sequence: 5 minutes, 11 minutes, 17 minutes.
Prime numbers. This was no longer random. It was responding. Gravitational modeling revealed subtle internal redistribution of mass. One region of the object accelerated relative to the rest by 0.15 kilometers per second, without thrust. Another region cooled rapidly in infrared bands, dropping by nearly 40 Kelvin against all expectations. At MIT, computational physicists ran simulations of every known exotic material configuration. None could replicate the observations. At the Max Planck Institute, material scientists confirmed that no ice-rock composite could undergo such changes without catastrophic fracture. Two interpretations began to dominate discussions. The first, the mainstream explanation, suggested that 3I Atlas might be composed of an unknown isotropic material formed in extreme interstellar environments. Under solar influence, internal phase transitions could trigger rapid reshaping and controlled energy redistribution. Supporters argued that humanity's understanding of interstellar matter remains incomplete. The second interpretation was far more troubling. It proposed that the changes were not passive reactions, but active adjustments. That 3I Atlas was monitoring its environment and responding accordingly. That the acceleration, reshaping, and emissions were coordinated. Dr. Alan Weiss of Harvard reportedly remarked during a closed briefing, "If this were a system built by us, we would describe this behavior as adaptive." Then came the second wave. 17 hours after the first shape change, a discrete surface feature, previously tracked consistently across all instruments, vanished. Not detached, not eroded, it disappeared simultaneously from optical, infrared, radio, and radar observations. No debris, no energy spike, no warning. Within minutes, the remaining structure compensated. Internal mass distribution shifted. Symmetry was restored. Emission pulses continued uninterrupted. At the same time, subtle effects were detected closer to home. Magnetometers aboard Earth-orbiting satellites registered a brief fluctuation, 0.3 nanoteslas, precisely synchronized with one of the emission pulses. Radio observatories reported momentary signal degradation over the South Pacific. Satellite navigation systems logged nanosecond-scale timing errors. Harmless, but unprecedented. Inside control rooms, conversations grew quieter. Data access restrictions appeared. Some telemetry streams were delayed. World governments were briefed privately, not on conclusions, but on uncertainty. No alarms were raised publicly, but no reassurances were offered either. As days passed, the rate of change slowed, but did not stop. 3I Atlas settled into a new configuration, smoother, more symmetrical, and measurably different from its original form. Emissions continued at lower intensity, now synchronized across multiple spectral bands. It was no longer evolving randomly, it was stabilizing. I remember staring at the live data feed as the latest update arrived. The numbers were calm, predictable, almost reassuring, and yet nothing about them felt safe. Because for the first time, we were not observing a slow-moving relic of another star system. We were observing a process unfolding faster than expected, faster than natural evolution should allow. In the quiet moments that followed, reflection replaced urgency. For centuries, humanity believed change in the cosmos occurred on vast timescales, millions, billions of years. But what if some objects operate on clocks we do not yet understand? Maybe we are not witnessing a breakdown of physics. Maybe we are witnessing a different set of rules. As 3I Atlas continues its passage through our solar system, instruments remain locked, recording every shift, every pulse, every anomaly. The data keeps coming, the models keep failing, and one question now dominates every discussion. If it can change this fast, what happens next? Subscribe to follow the next update, because the story of 3I Atlas is far from over.